right, select the expression that is equivalent to, oh, real quick, we are still working on the SBAC Practice questions 5. I'm just going to pick up where I left off in my last video, which is on question 10. Okay. Select the expression that is equivalent to the 12th root of 6.2 to the 10th power. So if we rewrite this, the index becomes the denominator, and I'm going to have 6.2, I should say the denominator of my exponent, so 12 is on the bottom, and the power inside is what's on top. So if I reduce this, I have 6.2 to the power of 2 goes into both of those, so I get 5 over 6. And since there's only one number, one term here, we could just write this as 6.2 to the power of 5/6. Okay, number 11 says select the expression that is equivalent to this. Now remember with radicals, if they have the same root here, so this is a 3 and this is a 3, you can multiply the insides. So I'm going to have the third root of 2 to the 4th times 2 to the 6th. And then because these two have the same base, you can add those exponents, and I get the cube root of 2 to the 10th. Now I look and I go, well, none of these match this. So we're going to do what we did in number 10, and we're going to rewrite this. So remember, the index becomes the denominator of the exponent. So I have 2 to the power of 3 goes on the bottom, and 10 goes on the top. So 2 to the power of 10 thirds, and that matches B. For number 12, it says select the expression that is equivalent to 7 to the power of 5 halves. So that's kind of going in the reverse order here. So our root is this. So I have the square root of 7, and then that 5 goes on the inside. So I look, and none of these match these. Okay, this one kind of matches it, but there's no 2 here. Now remember, you don't actually need the 2 written there. When you have the square root, we all know that there's a 2 here, so we don't actually have to write it. So it does actually match answer choice D. And then for number 13, it says choose the domain, so that's the x values for which the function is defined. So first of all, I see that this is a fraction, and I know that fractions cannot have a 0 on the bottom, right? That's undefined. So I don't want a 0 on the bottom. So what I'm going to do is I'm going to find out what value makes this denominator 0. So I set my denominator equal to 0, and I solve, and I get x equals -2. So my denominator here will equal 0 if x equals -2. So I cannot allow that. X cannot equal 2. So answer choice B matches that, and answer choice C has that. So not A and not D. So then I have to decide, is this other part included, or is it actually answer B? So let's see. I have a radical, and if we remember, the square root cannot be negative. So what number is going to make this negative? So x minus 4, I want to know what's going to make it less than or equal to 0, because that'll be a negative. So if I add 4, so x less than or equal to 4, if I add 4 to the other side, x less than or equal to 4 would make it a negative. So I don't want a negative, remember? That's what I don't want. So I need x to be greater than. X to be greater than or equal to 4. So if x is less than or equal to 0, it would make it a negative. So I need it to be greater than that. And so that's why C is my answer. And now the last two, numbers 14 and 15. So 14 says the inequality x to the power of 5/3 is greater than 1 is true for some values of x. Which description of the interval of x makes the inequality true? So the absolute value of x is less than 1. So let's see, the absolute value of x is less than 1. That's what answer choice A is saying. B is saying the absolute value of x is greater than 1. C is saying the absolute value of x is greater than 0. And D is saying the absolute value of x is less than 0. So let's think about what this means. The way that I kind of thought about this was I wrote it as the cube root of x to the 5th power, or the cube root of x, and you can put the 5th power on the outside. So let's see, what number is, the absolute value is less than or equal to 1. So what if x was 1/2? So is 1/2, is the cube root of 1/2 to the 5th power going to be greater than 1? Well, the cube root is way smaller than 1/2, and then raising that to the 5th power is also smaller than 1. So the cube root to the 5th power is smaller than 1, and I need it to be greater than 1. So it's not answer choice A. Okay, what's a number that satisfies this? So let's try the number 8. 8. The reason I chose 8, just so you know, is I'm taking the cube root, so I chose a number I knew was a perfect cube. So if I choose 8, I would get, see, the cube root of 8 is 2. 2 to the 5th power is, what is that, 32? So is that greater than 1? Yeah, it works for B. How about this? The absolute value of x is greater than 0. Well, 2 is also greater than 0, but I want to know, is it greater than 0 or greater than 1 that satisfies this? So let me try a number that's between 0 and 1. Let's try greater than 0. Let's try 1/8. Another thing we could actually think of is we just tried 1/2, and 1/2 is greater than 0, and it didn't work for 1/2. So that's another thing we can kind of think of here is if this 1/2 didn't work, it actually eliminated choice A and C. But let's just try 1/8 because I said I would. So the cube root of 1/8 to the 5th power is the cube root of 1/8 is 1/2 to the 5th power is 1/32. Is 1/32 greater than 1? No, it's not true for this. And then last but not least, I have the absolute value is less than 0. Well, the absolute value less than 0, let's see, what number could I plug in? If I plug in a negative 1/2, the absolute value makes that a positive 1/2. I actually can't think of any number, think about it, because any number I plug in here is going to be a positive number. I can't think of any number that will be less than 0. The absolute value of a number is less than 0. So that doesn't even work. So my answer choice is B, and that's my answer. Number 15. Given the formula A equals pi r squared, where A represents area and r represents the radius and has units in inches, select the appropriate measurement unit for area. So area equals pi, and then remember r squared is inches, so it's going to be inches squared. Pi being a number, so for my units, I'm going to have inches squared. So that matches C. It's not 1/inches because it's pi times r squared. It's not 1/inches squared, and it's not inches cubed, it's C. Good luck.